Hello everyone, welcome to Physics Online classes for class 11 students. Let us continue chapter 4 Motion in a Plane. Today we are going to study about Lemi's theorem and direction cosines of a vector. In the previous class we studied resolution of a vector into rectangular components. So here Lemi's theorem and direction cosines of a vector. So again these are related to resolution of a vector. If you understand resolution of a vector, then it is easy to understand Lemi's theorem and direction cosines of a vector. Now let us start the class. Before going to study about Lemi's theorem and direction cosines of a vector, let us observe this tabular column, and this is for different physical quantity. How to express in terms of x component and y component, how to write its magnitude and direction, that you can observe in this tabular column. The first column is related to physical quantities. For example, position vector, velocity, momentum, acceleration, force. So these are some example for physical quantity. Then we are going to represent these physical quantities along x-axis and y-axis because we consider only two-dimensional. For two-dimensional, for plane, we can represent these physical quantities along x and y-axis. Then how to write its x component and y component, then its magnitude, direction. We already studied all these terms in the previous class in resolution of a vector. Remember, we considered a vector R. So this vector is split into two components. For example, the first vector is along x-axis, we can take it as Rx. Second vector is along y-axis, we can take it as Ry. When we combine Rx and Ry, that gives resultant vector R. So these are the components of vector R. Rx and Ry are the component of vector R. Is it clear? So the first component is along x-axis, second component is along y-axis. If these two components are at right angles to each other, then we can call it as rectangular component. Then we found the value of Rx. Rx equal to we got R cos theta, Ry equal to we got R sin theta. You can remember in the previous class we studied this is angle theta. Just we draw a line perpendicular to both Rx and Ry. If theta is here, this is adjacent side, this is opposite side, and this is hypotenuse. Right? So we want the value of Rx. Rx means we can take the angle here. The trigonometric function suitable is cos theta because cos theta equal to A by H. So A divided by H, because opposite side we don't know. A by H means cosine function is suitable. So cos theta equal to A divided by H. So we can write cos theta equal to, we can take it as O, this is A and this is B. I am going to write OA divided by OC. OA by OC means OA is equal to Rx divided by OC equal to R. So Rx equal to R cos theta. Similarly, for the y component or for Ry component, here if angle theta is here, here also I can take theta. Right? Angle theta is here, this is opposite side and this is adjacent side and this is hypotenuse. So we want the value of Ry. Here we know the value of opposite side and hypotenuse. So the suitable function is sin theta. Sin theta equal to O divided by H. Here theta is here, opposite side is OB divided by hypotenuse is OC. OB value is Ry, OC value is R. So Ry equal to we got R sin theta. So R cos theta is the component of Rx and Ry equal to R sin theta. So these are the components of vector R that we have studied in the previous class. And also we derived an expression for magnitude and directions. So here that is general equation. Now the same equations we are going to apply for some physical quantity. These are some examples. You can observe the first point. The first quantity I am going to consider position vector. Position vector is denoted by vector r. Vector r equal to, I am going to write its component as ax and ay. Is it clear how to write its position vector? So a vector r equal to ax, this is first component along x-axis, ax is magnitude and its direction is I cap, plus ay is the second component along y-axis and its direction is given by j cap. How to write the position vector? Vector r equal to ax I cap plus ay j cap. Then how to write its x component? X component will be x equal to r cos theta, because here the position vector is denoted by r. Then y component is given by y equal to r sin theta. R cos theta and r sin theta are the x and y component of position vector. Then the magnitude is given by r equal to square root of x square plus y square. So we already derived magnitude in the previous class. So it is given by, in generally we can write r equal to square root of rx square plus ry square. So this equation we already derived. Similarly, position vector is given by r equal to root of x square plus y square, and direction is theta equal to tan inverse of y divided by x. Right, then come to the second point, velocity. Velocity is again a vector quantity. It is a physical quantity. We are going to express along x and y coordinate system. See here, vector v equal to, how to write here? Vx I cap plus Vy j cap along x and y axis. Vx I cap plus Vy j cap. Then its x component Vx equal to V cos theta, y component is Vy equal to V sin theta, and its magnitude is V equal to square root of Vx square plus Vy square, and its direction is theta equal to tan inverse of Vy divided by Vx. Then similarly, momentum. So linear momentum is denoted by P. So this is denoted by P. So vector P is equal to Px I cap plus Py j cap, and its x component is Px equal to P cos theta and y component is Py equal to P sin theta. Magnitude is P equal to square root of Px square plus Py square, and its direction is theta equal to tan inverse of Py divided by Px. So this is about momentum. Then come to the next term, acceleration. We know that acceleration is denoted by vector A. Vector A is equal to ax I cap plus ay j cap. So its x component is a cos theta, y component is a sin theta. Then magnitude is a equal to square root of ax square plus ay square, and its direction is theta equal to tan inverse of ay divided by ax. Similarly, next term is force. Force is denoted by F. F equal to, how to represent force? Fx I cap plus Fy j cap. Then its x component is F cos theta, y component is F sin theta. And its magnitude is given by F equal to square root of Fx square plus Fy square. Then the direction is theta equal to tan inverse of Fy divided by Fx. So these are just some example how to represent, how to write its components and what is the magnitude and directions. For example, if I am going to take another example here, sixth one, here we consider some physical quantities. I am going to consider angular velocity. Angular velocity is denoted by the symbol omega. This is not W, this is omega. Yes, now tell me how to represent angular velocity. Vector omega equal to omega x I cap plus omega y j cap. And its x component is omega x equal to omega cos theta. Y component is omega y equal to omega sin theta. And its magnitude is omega equal to square root of omega x square plus omega y square. And its direction is theta equal to tan inverse of omega y divided by omega x. So in this way, you can write the components of given quantity, right? So this is all about resolution of a vector. Now let us study about Lemi's theorem. Remember, Lemi's theorem is not for your syllabus, but this Lemi's theorem is very helpful only for your NEET and JEE competitive examination. So you can observe the statement here. If three coplanar forces, coplanar means the forces which are in the same plane. If three coplanar forces acting at a point are in equilibrium. Suppose if all the three forces are acting in a same plane, then they are in equilibrium. Then each force is proportional to sine of angle between the other two forces. What is the statement? If three coplanar forces acting at a point are in equilibrium, then each force is proportional to sine of angle between other two forces. Observe this diagram here. So we consider three forces, that is F1, F2 and F3. F1, F2, F3, these are the three forces acting at a same point. You can observe acting all the three forces at the same point in a same plane. Then each force F1, F2, F3, these forces are proportional to sine of angle between other two forces. For example, if I am going to consider F1, F1 is the force and it is proportional to sine of angle between other two forces. Exactly opposite to F1 is what? Alpha. So, sine of angle alpha between other two forces. Right? If I am going to consider F3, F3 opposite is what? Gamma. Gamma is angle between F1 and F2. So, if three coplanar forces acting at a point are in equilibrium, then each force is proportional to sine of angle between other two forces. Right? See here, I am going to consider the first force F1. This F1 is proportional to, it is proportional to sine of angle between other two forces. Which are the other two forces? F2 and F3. Angle between other two forces is what? Alpha. F1 is proportional to sine alpha. Right? Similarly, second one is what? F2 force. F2 is proportional to sine of angle between other two forces, means F2 opposite is what? Beta. Beta is angle between other two forces F1 and F3. So F2 is proportional to sine beta. Similarly, come to the third one, F3. F3 is proportional to the opposite side is what? Gamma. Gamma is angle between F1 and F2. So F3 is proportional to sine gamma. Right? So here we can consider F1 divided by sine alpha equal to F2 divided by sine beta is equal to F3 divided by sine gamma. This is the equation for Lemi's theorem. What is the equation? F1 by sine alpha equal to F2 divided by sine beta is equal to F3 divided by sine gamma. So just you remember the statement and its equation. Is it clear? So what is the statement? If three coplanar forces acting at a point are in equilibrium, then each force is proportional to sine of angle between other two forces. What is the equation? F1 by sine alpha is equal to F2 divided by sine beta, and it is equal to F3 divided by sine gamma. So this equation we can use. Then come to the second one, that is direction cosines. See here, the direction cosines. Here I am going to consider L, M and N. L, M and N are the direction cosines of a vector. So these are the cosines of angles alpha, beta and gamma, which a given vector makes with the x-axis, y-axis and z-axis respectively. See the diagram, then only you can easily understand here. Observe this diagram. I am going to consider vector A. This is vector A. So this vector A is resolved into three components. The first vector is along x-axis. Let us take it as AX. The second vector is along y-axis. Let us take it as AY. Third component or the third one is acting along z-axis. Let us take it as AZ. AX, AY and AZ are the components of vector A. Is it clear? So vector A is split into three components along x-axis, y-axis and z-axis. So here the angle alpha, observe the first angle. This angle is between vector A and its x component. And then second one, angle beta, observe this angle. This angle beta is between vector A and its y component. Then similarly gamma, gamma is angle between vector A and its z-axis. See here once again, alpha is between AX, beta is between AY, gamma is between AZ. Is it clear? Alpha, beta, gamma. Then their directions are given by the unit vectors I cap, j cap and k cap. Now I am going to take L, M and N. So what are L, M and N? Observe this statement. L, M, N. These are the direction cosines. Yes. Yes. If alpha, beta and gamma. So these are the angle made by vector A with x, y, z axis. Right? So alpha, beta, gamma are the angle made by vector A with x component, y component and z component. Then cos alpha, cos beta and cos gamma. These are the direction cosines. So why we have to consider cos or cosine function? Observe here, alpha is angle between vector A and AX. If alpha is here, angle is here, so this will be adjacent side and this will be hypotenuse. We know only adjacent side and hypotenuse which is the suitable function, cosine, because we know that cos equal to A divided by H. This is the suitable function. When it comes to gamma, gamma is here. This will be adjacent side and this will be hypotenuse. So here the suitable trigonometric function is cosine. So we are going to consider cos alpha, cos beta and cos gamma. These are direction cosines. So we can write for the x-axis L equal to cos alpha equal to, the equation becomes AX divided by A, adjacent side divided by hypotenuse. So we can write AX divided by A. Similarly, M equal to cos beta equal to, we can write adjacent side divided by hypotenuse. So AY divided by A. Then come to the next one, gamma. N equal to cos gamma equal to AZ divided by A. This will be adjacent side and this is hypotenuse. So L equal to cos alpha equal to AX by A. M equal to cos beta equal to AY divided by A. Similarly, N equal to cos gamma and this is equal to AZ divided by A. Now I am going to squaring and adding all the above equations. Observe here, squaring and adding above equations. Yes, squaring and adding cos square alpha plus cos square beta plus cos square gamma. This is equal to squaring and adding. So we can write ax square by a square plus ay square divided by a square plus az square divided by a square. Or we can write, or you can take LCM a square, ax square plus ay square plus az square divided by a square. Ax square plus ay square plus az square. So these are the component of vector A. Vector A equal to what? When we combine all its component, again we will get the same effect. Ax plus ay plus az, that gives vector A. If we are squaring the component, then it will be a square. So in place of ax square plus ay square plus az square, we can write a square. A square will get cancelled. Remaining is 1. So what it gives here? Cos square alpha plus cos square beta plus cos square gamma is equal to 1. So this is the direction cosine of a vector.